So we have another proof here. We'll do a couple more of these, make sure you're getting the hang of this. And so this is not exactly number 4 out of your book. I've changed it a little bit just to make it work better for what I want to show you here. But at any rate, we want to do conditional or indirect proof with this one. So we look at the conclusion, and what do you know? In fact, in this case, the main operator of the conclusion is a horseshoe. And so this will be a fairly straightforward conditional proof. We will indent. We will assume the entire antecedent here of the conclusion. So let me remind you that, again, in many cases, when you're doing conditional proof in predicate logic, if the main operator of the conclusion is the quantifier, it's not, right? The main operator here is the horseshoe. But if it were the quantifier, you don't assume the quantifier. But in this case, because the main operator is the horseshoe, we're going to assume everything to the left of that main operator horseshoe, which in this case does include the quantifier. So you have to be sure you understand when you're supposed to assume a quantifier and when you don't. In this case, then, we're trying to get there exists an x, bx. Again, I strongly recommend you put down that note here to remind you as to what you're doing. All right. I like to use my assumption right away here. I've got an A predicate. There's an A predicate there in number 1. So I'm probably going to try and get those to work together. But of course, I can't at this point because I've got quantifiers here. So I'm not going to be able to do like a modus ponens with 1 and 3, right? When the quantifiers are the main operators, we can't do modus ponens. You can only do modus ponens when the horseshoe is the main operator, of course. So we're going to have to remove quantifiers. Good news. We can remove quantifiers for both 1 and 3. They're both the main operators there, so we can remove them. The question will be, which one do we remove first? Right? Of course, the universal quantifier is listed here in premise number 1. You might think, oh, let's just do that one. But of course, we need to remember, right? Do EI first. We saw that before. You want to remember, do EI first. So we're going to remove that quantifier here. And the reason for doing EI first is because we have to be careful about what letter we choose here when we do EI. We can't choose a variable, and we can only choose an individual constant that has not appeared already in the problem. We don't have any individual constants, so we can choose A or some other individual constant. But the reason we do EI first is because now when we turn to do our UI step, the good news is UI is completely flexible, right? UI, you can assume any letter you like here. You can choose any letter you like there, I should say. And of course, once we do EI first, we'll know which letter we want to choose. All right? I should just back up a second and just note here that in our assumption, note that this variable here was not free. We have not assumed any free variables. So if we wanted to or needed to do universal generalization while we're indented, we could. We'll see what happens. All right. So 4 and 5 here, I hope, looks very reminiscent of modus ponens, which gives us CA that's great. We're getting some work done. Now, I want to keep in mind that I have not used line 2 here, which has a C in it. And here's a C in it. Of course, this C has the existential quantifier attached to it. But we will not be tempted to remove these quantifiers from line number 2 because the main operator is the horseshoe. So they are stuck on there. We're not going to remove those quantifiers. Can we add on the existential quantifier to line 6 on the other hand? Why, yes, we can. Not UG, of course, but EG. When we're adding the existential quantifier, that's EG on line 6. All right, so we got that. We know we want to use line 2. P, horseshoe, Q, and P again is once again a modus ponens. So modus ponens 2 and 7 gets us there exists an x, bx. Now that we finally used our second premise, let's remind ourselves what we're trying to get. Well, what do you know? We wrote it down right here. We're trying to get there exists in x, bx. We got it right there. So once you get what you're looking for in conditional proof, you simply unindent, and the process is always the same. You write down your assumption. You write down a horseshoe. And then you write down the last thing that was indented. And that's your conditional proof step. In this case, lines 3 through 8. And what do we know? That matches our conclusion in this case. So we are completely done with this problem. All right? So this one is a little bit easier only because we had a horseshoe as the main operator of our conclusion. So we could assume everything to the left of that main operator horseshoe, get everything to the right, and then we're done, like we would have been typically in Chapter 6. All right, so we'll go to the next video then, and we'll do one more of these proofs to make sure you're really getting the hang of this technique when it comes to predicate logic.